So let's go ahead and jump into the scientific method. The first thing I want to talk about is that the scientific method is not really steps that you go through one right after the other, you know, in a straight line, basically. It's more like a process, and you can go back and forth between steps depending on what happens during your research, during your experiment. So you start off with a question, and then you want to go to research. You are going to research everything so that you can become an expert on that topic. Sometimes that research will lead to more questions, or it'll lead to a modification of your question. So you can go back and look at that. After that, because you're educated now, because you're an expert now, you're going to go to your hypothesis, which is an educated guess. And then using your hypothesis, you're going to design an experiment. Your hypothesis has to be testable. So you design an experiment for that. And while you're doing your experiment, you're collecting data. Sometimes when you're collecting data, something went wrong, or you noticed something that was very interesting, you can actually go back and redesign your experiment, or change some elements of it, or start all over again. So that's why you can go back to do a different experiment, or just modify it a little bit. After you've collected your data, you analyze it. This is when you're going to be creating graphs. And then you use all that information to draw your conclusion. And during your conclusion, you're going to be going back to your hypothesis. You're going to be stating your hypothesis. You're going to state whether it was right or wrong. If you were to do this over again, would you modify your hypothesis? Or if you were to do another experiment, what do you think, would be the turnout with that? So that's why it goes back to hypothesis. And then finally, the last thing that you do is you go forward and you make a report so that you can share your findings with other scientists. And that's really important because scientists need to show you what they've been doing, and that's how they share the results. So if they've invented something, or they discovered a new type of drug or anything like that, then this is how they will share it with the world. So let's go ahead and dive right in. So the question, like I said, it's a process it's going to start off your process. And you're going to be asking about something that you observe. Why, how, when, what. And it has to be testable, something that you can design an experiment with. For example, with our pet measurement lab, we are asking how big are the pets going to get. Then you're going to do your research. You don't start from nothing. You can talk to experts. You can go to the library. You can find information from anywhere, and you can see what other experiments that are similar to yours have been done, or if yours has ever been done before. That can be really helpful. Then you go on to your hypothesis. You have educated yourself in the topic, and you're going to make an educated guess. It's important that your hypothesis is testable. In other words, you can design an experiment around it. It cannot be an opinion. It has to be something that you can actually measure. Then you go on to your experiment. You have to make sure that you have variables, your independent and your dependent variable, which we'll talk a little bit more in a second about that. And you have to make sure that everything in your experiment is fair. You're only changing one variable. For example, if I am doing a experiment with plants and I want to test fertilizers, so I go to Lowe's and I buy fertilizer A, B, and C, and I buy 3 plants. And I'm going to give each of them a different fertilizer, and I want to see which one is the best fertilizer. I have to keep everything else the same. I have to control everything else. I have to give them all the same amount of water and the same hours of sunlight and keep them in the same temperature. They have to be the same kind of plant. It would not be fair if I changed more than one thing, more than just the fertilizer, because then at the end of the experiment, I'm not going to know what made the difference. I'm going to say, oh, look, plant number 3 grew the most, but was it the fertilizer, or was it because it had the most hours of sunlight? I don't know. So that's why it says that it's fair. It also has to be repeatable. In other words, if you were to do the experiment again, you would pretty much get the same results. Or if somebody else were to do your experiment, they would get the same results. And so in class, I talked a little bit about the vaccine controversy and how a scientist came out with a study that claimed that vaccines caused autism, and it wasn't true. And so all these people started saying, oh my goodness, I'm not going to give my kids these vaccines because it causes autism. And other scientists looked into his research, and it turned out that his results were not valid. They tried to repeat his experiment, and they did not end up with the same results. And his conclusion wasn't even really based on the data that he had collected. And all these people started believing that their kids were going to get autism if they gave them these vaccines, and all these kids ended up getting sick, and there's epidemics now because people aren't vaccinating. And so that's why it's really, really important that all science is repeatable, it's testable, and that it's valid. So keep that in mind. Once you're doing your experiment, you start collecting your data, and for in our case, right, we're writing it down in our journal. You need to make sure that you're recording it accurately, that you're not making mistakes while you're doing it, and it cannot, sometimes it's not going to fit your hypothesis. You're not going to change your data so that it fits your hypothesis, which is what that guy did. And you have to use correct measurements. This is why I'm always getting after you guys about make sure that you're using grams when you're doing the mass on your PET measurement lab. Make sure that you're using centimeters when you're doing the length and all of that stuff. Then you analyze your data. So we make graphs so that we can see visually what's going on, and it's just an easier way to read things. And then you can look at it and say, hey, did I get any results that were unexpected? Or maybe was there an error? For example, one year I forgot to put the pets in water at the end of the day, and everybody's results were weird. There was a drop on that day because the pets drank because they weren't in the water anymore. And so that's something that you would analyze. And then for using what you've analyzed, using the data that you analyzed, you are going to come up with a conclusion. And you're going to be able to say, was my hypothesis right or was it wrong? If I were to do this again, would I go back and revise it? What could be done after? And then you make your report. And so this is how scientists share their results. You will be doing a report for the PET measurement lab. You could also do a science fair, or you could even go publish in a science journal, which is what scientists do. So that's how scientists share their information. Okay, so again, remember that the scientific method is all about a process that you can go back and forth in. It's not just, a one kind of path that you take. You can go back and do steps multiple times. So let's talk about variables. An independent variable, an easy way to remember this is to remember the I. An independent is the factor that I changed. So this is changed on purpose. So this is what you are doing on purpose. For example, we are putting the pets in water for 5 days. That's what I did on purpose. This is also known as the cause. Remember, we used to do cause and effect in elementary school. And so this is kind of the cause, and then the dependent variable is the effect. And when we graph this, we have our x-axis and our y-axis up here. The independent is always going to be at the bottom. Okay, and so we're going to be graphing our data, and our independent variable down here is going to actually be our days that we've had the pets in the water. Our dependent variable is the effect. And so this is this is going to change because of the independent variable. And this is really important. This is what we're measuring. So the length of our pet is going to be the effect, right? The mass of our pet is going to be the effect of putting it in water. And when we graph this, here's my x and my y again. My dependent is on the side. Okay, so again, the dependent is what is affected. And then we have our controls. I talked a little bit about this already. These are the factors that remain constant or unchanging. We're not going to, have multiple variables. For the pets, we only changed the amount of time in the water. I can't change the temperature also, or, the kind of water, if it's salt water or Kool-Aid. I can't do that. I can only change one thing at a time. That way, at the end of the experiment, I know exactly what it was that had the effect on the growth of the pets. Okay, so let me know if you have any questions on the scientific method. I'll see you in class.
Thank you for visiting Somo's YouTube channel. Look for us on Facebook, Instagram, and Snapchat. And don't forget to like and subscribe.